Welcome back. So let's continue with example 1 before we proceed with the next subtopic. So this question is a plane of progressive wave is represented by the equation given where x and y in meter and t in second. So find the first one, amplitude, next wavelength, period, frequency, velocity of the wave, direction of the wave propagation, maximum velocity of the particle. So for the first question, to get the amplitude, we can simply compare the given equation here with the general equation to get the value of amplitude equivalent to 20 meter. For question number B, to get the wavelength, we can simply use the formula lambda equal to 2 pi over k. The value of k here, we can get it also from the given equation, which is 0.5 pi. And the value of lambda is 2 pi over 0.5 pi equal to 4 meter. Next, the value of period. So the formula of period T is equal to 2 pi over omega. And the value of omega is equal to 2 pi after we compare with the general equation. So we have 1 second for the value of period. Question number D, for the frequency, we have 1 over period and we can get 1 hertz. For question number E, velocity of the wave, we have V equal to F lambda. By insert the value of frequency and lambda, we can get 4 meter per second. Question number F, the direction of the wave propagation. By referring to the given equation, there's a negative sign in the equation, indicates that the wave propagates to the right. Question number G, the maximum velocity of the particle. So before we get the maximum velocity of the particle, we can have the general equation of Vy by differentiate the general equation of the displacement with respect to time, and we will get A omega cos omega t plus minus kx in bracket. And to get Vy maximum, we should put our cos omega t plus minus kx equal to 1. So we have Vy maximum equal to A omega. By insert the value of amplitude and omega, we can get 40 pi meter per second. Now, we have our next subtopic 10.2, superposition of wave. And we have the principle of superposition of wave. So first, we have the interference. It's defined as an interaction or superposition of 2 or more wave motions in the same region of space to produce resultant wave. So according to the principle of superposition of wave, when 2 or more waves are moving in the same region, the resultant displacement at any point is the vector sum of their individual displacement at that point. We can simply simplify into an equation y equal to y1 plus y2, where y1 and y2 are the displacement of individual pulses at that point. So in this table, we are going to differentiate between constructive interference and destructive interference. So constructive interference occurs when the displacement caused by 2 pulses are in the same direction. For example, both are in positive or both in negative. Whereby for the destructive interference, it occurs when the displacement caused by the 2 pulses are in opposite directions, one positive or one negative. So for the constructive interference, it will produce a displacement that is larger than the displacement of either of the individual waves. Whereas for the destructive interference, it will produce a displacement that is smaller than the displacement of either of the individual waves. So for example, at the beginning, when t equal to 0, we have 2 approaching pulses, y1 and y2. So after some time, when t equal to t1, 2 pulses will completely overlap. For the constructive interference, they will overlap and combine, become larger amplitude 2A. But for the disruptive interference, they produce zero amplitude. Next stage, at t equal to T2, both emerging pulses will remain unchanged. Next, we have standing wave or stationary wave. So the definition of the standing wave or stationary wave is defined as a form of wave in which the profile of the wave does not move through the medium. So how to produce the stationary wave is formed when two progressive waves of same speed, frequency, and amplitude which are traveling in opposite directions are superimposed. So this animation shows the formation of a stationary wave indicated by the red color wave, created by the combination of two progressive waves. One is blue color and another one is a green color wave. So in observing the stationary wave, there is no sense of motion in the direction of the propagation of either of the original wave. It's called stationary wave because it does not appear to be traveling. However, we can describe the stationary wave by nodes and antinodes. So the node is defined as a point at which the displacement is zero, where the disruptive interference occurs. So here are the points of nodes. For the antinodes, is defined as a point at which the displacement is maximum, where the constructive interference occurs. So here are the antinodes. So in this slide, we are going to learn the equation of standing wave. So assume we have two waves with same amplitude, frequency, and wavelength traveling in opposite direction in the medium. So we have y1 and y2. One negative sign, one positive sign, indicates they are having in the same different directions. So both waves interfere according to the principle of superposition. Therefore, y1 plus y2, we will get 2a cos kx sine omega t. This is the general equation of the stationary wave. So please take note that 2a cos kx is the amplitude of the stationary wave at any x position. 2a itself is the maximum amplitude of the stationary waveform, and a is the maximum amplitude of individual progressive waves. Schematic representation of the standing wave with an indefinite number of nodes and antinodes. One start counting at time t equal to 0 when the displacement y is a maximum at s equal to 0. So for example, the distance between adjacent antinodes is lambda over 2. So we have antinodes to the next antinodes is lambda over 2. Next one, the distance between two adjacent nodes is lambda over 2. So from one node to next node also lambda over 2. The distance between a node and an adjacent antinode is lambda over 4. So we have nodes to next and another antinodes is lambda over 4. Then the amplitude of the vertical oscillation of any particle in the string depends on the horizontal position x of the particle. Each particle vibrates within the confines of the envelope function a cos kx. So we have example 2. Two harmonic waves are represented by the equation below, where y1, y2, and x are in centimeters and t in seconds. So we have y1 and y2. So write an expression for the new wave when both waves are superimposed. So we can have the general equation before we have the specific equation here. So we have y equal to 2a cos kx sine omega t. So substitute the amplitude of individual wave is phi. So we have 2 times phi cos 2 pi x sine omega t, where x and y in centimeters and t in seconds. Question B, determine the wavelength, frequency, and velocity for both harmonic wave. So to get the lambda, we can have lambda is 2 pi over k, and the value of k here is 2 pi. So we have 1 meter for the value of lambda. So for the value of omega, we can simply have 2 pi f, and f equal to omega over 2 pi. So omega is equal to pi. So pi over 2 pi, we get 0.5 hertz. And for velocity, we can have f lambda with the value of 0.5 meter per second. Question number D, determine the distance between two adjacent nodes and a node and adjacent antinode of the standing waveform. So the distance between two adjacent nodes will be equal to lambda over 2 equal to 1 over 2 meter. Distance between the nodes and antinodes will be equal to lambda over 4 is equivalent to 1 over 4 meter. So this table distinguishes between progressive and standing wave. The first one, progressive wave, the wave profile moves, but for the standing wave, the wave profile does not move. For the second part, all particles vibrate with the same amplitude for the progressive wave. However, for the standing wave, particles between two adjacent nodes vibrate with different amplitudes. Next will be neighboring particles vibrate with different phases for the progressive wave, but for standing wave, particles between two adjacent nodes vibrate in phase. For progressive wave, all particles vibrate, but for standing wave, particles and nodes do not vibrate at all. And for progressive wave, it produced by disturbance in an elastic medium, but for standing wave, produced by the superposition of two waves moving in opposite direction. And the last one, for the progressive wave, it transmits the energy, but for the standing wave, energy is not transmitted down the string, but stays in the place in the string. So we are going to proceed the next subtopic in the next video. Thank you for your watching.